Good morning. So innovations in TPU. So a little bit about the company. We are a small private company out of Italy. We have branches in 4 continents, in Brazil, in US, and in China. And we've always worked on film. So we have an expertise in films and in graphics. We work in the flexo, offset, digital, and screen printing world. The topic today is promise on TPU. Okay, TPU is a very promising product for print electronics. However, TPU has some, why? Because TPU has unparalleled flexibility. It offers exceptional elasticity and resilience and surpasses traditional material like polyester, which is not so flexible. It has superior softness, which is very nice for wearable electronics. Comfort and tactile appeal, essential for consumer-facing applications. And the last thing, which is the most important, is textile compatibility. Seamlessly integrates with fabric, opening new possibilities in wearable electronics. You can bond the TPU very easily to pretty much any fabric, especially stretchable fabric. But there are some challenges with TPU, especially in the printing process. So you have poor material flatness and you have surface stickiness. I don't know if anybody of you has printed with TPU. Very often the TPU gets stuck to the printing machine. The second thing is incurring problems. So that the incuring problems, so that whenever you have to cure the ink, you lose dimensional stability and the surface becomes wavy. And last but most important is the transfer process. You know, when you transfer the TPU on the fabric, the TPU is sensitive to heat, and you lose fidelity because as you go up to 160 degrees to transfer it to the fabric, the fidelity goes away. So this is the last thing, dielectric layer application and transfer. So when you do need to put dielectric to coat dielectric on TPU, you lose some of the stretchability. And also the dielectric may, as much as it can be flexible, it may delaminate over time. So what we have done, our solution is ELECROM STRETCH TS. The ELECROM Stretch was designed with 3 layers. One layer is a printable side, which has a melting temperature of 160 degrees Celsius. The second layer is a hot melt layer, melts at a lower temperature, 130. And the third layer is a heat stabilized PET with a matte surface that will release from the TPU after the TPU is heated. And then the second part is so this 2 layers technology, the advantage of what are the advantages that this technology gives you. So you have a good product flexibility and a good bond with the fabric. And the second thing is the excellent release from the mesh. So we have a special matte surface that releases from the mesh easily. And the last thing, with the stabilized PET, you have good dimensional stability, especially if you want to print multiple layers, then the layers will stay stable. So the other solution is the ELECROM STRETCH ENCAPSULATE. So it's an encapsulation product that's made of TPU that substitutes the dielectric, or it can be also used with the dielectric, but it depends on the application. And so what this does is it is again with the 2-layer technology. So you have the same idea of the printability, the fidelity, and the bond with the TPU. And then you have the matte surface. So you have the same idea of the good release from the mesh. And the last thing is made with a silicone paper carrier. So because at the end you use it only for the last transfer, you don't need a polyester carrier, but the paper carrier is good enough for the transfer to the fabric. So I put together a small video. The idea came from failed project from one of our customers